Hello and welcome to the next lesson in our series of Matthew lessons. We're going to be talking about average rate of change today, and let's get started. Okay, so our goals for this lesson are to be able to both calculate and interpret the average rate of change of a function over a specific interval. You also should be able to estimate the rate of change from a graph or table. And I'm not saying like look at something and be able to say, oh, that slope or that average rate of change is this. It's more of understanding, is it increasing, is it decreasing, is it increasing by a lot, decreasing by a lot, that type of stuff. Alright, here's some vocabulary that's going to be useful in today's lesson. Slope is a line, surface, or plane in which one side is higher than the other. Increasing occurs when a value is going upward to the right or the slope is positive. Decreasing occurs when a value is going down to the right or the slope is negative. Rate of change, the relationship between two variables and how they change. The speed in which a value, our dependent variable, changes in relation to the independent variable, which is often time. Average is a value to represent the center of data or the typical data value. A function is a relationship that maps a set of inputs to a set of outputs, in which every input value maps to exactly one output. That's the important part right there. An interval is a location that is the span from one value to another and is based on the independent variable of a function or graph. Alright, let's move on with our lesson. So the average rate of change, here's our equation. We have f of b minus f of a all divided by b minus a. My y value, that f of b is the y value for when x is b, that f of a is the y value when x is a. You have all probably seen it more like this. Y sub 2 minus y sub 1 all divided by x sub 2 minus x sub 1. And this is the exact same thing as slope. So really what we're going to be finding today is the slope between 2 points. Alright, hopefully you have a chance to write that equation down and then we can move forward. So we're going to be given our points in interval notation. So when we're finding this average rate of change between an interval, we're going to be given two boundary points. Where's my starting point? Where's my ending point, and what's the slope or average rate of change between those two? So we're going to have to end up, we're going to be given x coordinates. We want to find the y coordinates that go with it. Okay. When finding the average rate of change over an interval, we're looking for the average slope, okay, between those points. So we're going to have to find coordinate points. So here's my steps. We first identify the coordinating output points, so the y values that go with the coordinating input points, the x values. I gotta find the y's that match up with my x's. That's my first step. Then we find the difference of the output points, f of b minus f of a. In physics, this is going to be called change of y. This little triangle thing right here, this is the Greek symbol delta, and it means change. So we're going to find the change in y, find the difference of the input points, b minus a, so the change in x, how wide is it, how far apart are they on the x coordinate. And then in step 4, we're just going to divide the difference. So really what that means is I have the change of y divided by the change of x. Now, we just have to simplify the solution. Alright, so let's get an example here. Okay, so I'm trying to find the average rate of change from negative 11 to 0. So what this means is I have my x point at negative 11 to when x is 0. So I'm trying to find the average slope between those 2 points right there. So what I got to do is I have to first identify my y values that go with the x's. So when x is negative 11, y is negative 58. When x is 0, y is negative 1. Alright, so I've identified my y values that go with the x's. I like to kind of identify these things, so we can do a couple different ways. If this is A, this is f at A. If this is B, this would be f at B. We could also say x sub 1, y sub 1, x sub 2, y sub 2. That's a weird 2. Alright, so either way is fine. This is how it would work. We can then plug this into our formula. So I'd say negative 58 minus a negative 1. It doesn't matter which one I go first in this order. What matters is that if I choose negative 58 first here, negative 11, the coordinate x has to go first as well. Minus 0 up here. Okay? So we're just plugging stuff into our equation. I did that a little bit backward than what the equation did, but that's fine. Alright, so now we're going to find, look, I have my change of y up there and my change of x on the bottom here. So I have negative 58 minus a negative 1. When I am subtracting a negative, this is going to turn to a positive. So negative 58 plus 1 is a negative 57. Negative 11 minus 0 is still a negative 11. When I simplify that, those negatives are going to cancel out, and I get 57 divided by 11. There's my average rate of change, or my slope. Okay, now this is a now you try problem. I want you to find the average rate of change. Pause the video and see what you can figure out. Alright, welcome back. Hopefully you paused the video for just a little bit and tried to work this problem out. I'm going to work it out right now. So my first step, find my coordinating y's that go with my x values that I'm giving, negative 6 to negative 2. So I have 5 goes with negative 6, negative 11 goes with negative 2. Okay, now I can plug stuff into my formula. I'm going to say negative 11 minus 5. So my y sub 2 minus my y sub 1. Then I'm going to do x sub 2 minus x sub 1. So negative 2 minus a negative 6. So negative 11 minus 5 gives me negative 16. Oh, there's that minusing a negative again. That gives me a plus. So negative 2 minus 6 is going to give me a positive 4. I'm going to erase that. Change that minus there. There we go. Okay, so it gives me a positive 4. Now I can simplify. Negative 16 divided by 4 gives me negative 4, and there is my slope. Okay, so we can also do the exact same thing on a table. So if we want to find the average rate of change from 2 to 5, the steps are exactly the same. I have 2 here. I have 5. I'm going to find my coordinating y values. So when x is 2, my y is 4. When x is 5, my y value is 25. Now we can just plug this in. So once again, I'm going to say this is A, this is f at A, this is B, this is f at B. Okay, plug this into my equation. 25 minus 4 divided by 5 minus 2. Remember my change in y, my change in x's. 25 minus 4 is 21. 5 minus 2 is 3. When I simplify that, I get 7. So my average rate of change is 7. And to interpret that, let's talk about that a little bit, is for every 7 that I move up, so every 7 that I move up on my output, I'm going to increase 1 by my input, which makes sense here. So I'm increasing here, right? And these numbers are increasing, so both numbers should increase at a constant rate. Well, not at a constant rate, but my average between these two. Okay, here's a now you try problem. Pause the video, and then come and check in. Okay, so I have my x values, 1 and 4. I find my coordinating y values here. When x is 1, y is 1. When x is 4, y is 16. Now I can plug these in. 16 minus 1 divided by 4 minus 1. 16 minus 1 is 15. 4 minus 1 is 3. 15 divided by 3 is 5. There's my average rate of change. Okay, one last now you try problem. We're just going to set this up. We're not going to worry about simplifying and all that stuff. Okay, so when x is negative 1.19 to when x is 0. Okay, when x is negative 1.19, we get negative 7. When x is 0, we get 5. So I'm going to say 5 minus a negative 7, all divided by 0 minus a negative 1.19. Okay, minusing a negative gives me a plus. So 5 plus 7, that's going to be 12. 0 minus a negative 1.9, that's a plus. Positive 1.19. I would just type that in my calculator. But that makes sense. It's a positive slope. I should have a positive here. It's pretty steep, so that makes sense. Alright, so that's our average rate of change lessons. If you have any questions, please feel free to come talk to me or a tutor, and we'd be happy to help. Thanks.